Good day, everyone. I am Archibald B. Claro, and today we're going to solve some problems involving the topics of midterm in Calculus 3, specifically the topics in Module 3. So without further ado, let's start. In Module 3, there are three topics. It includes first, function of more than one variable. Second is limits and continuity of functions of more than one variable. And lastly, the partial derivatives. Now the objective, after this video, you're able now to graph the function of more than one variable. Second is to determine the limits and continuity. And lastly, identify the first and higher order partial derivatives. So without further ado, let's start solve some problems involving the topics, the first topic of Module 3, which is the function of more than one variable. So I have here a problem. We have sketched the graph of the function. We have item number 1. We have function of x and y is equal to square root of 4 minus 4x squared minus y squared. And number 2 is function of f and function of x and y is equal to 10 over x squared plus y squared plus 1. Now let's start with item number 1. So we have function of x and y is equal to 4 minus 4x squared minus y squared. Now, before we're going to graph this function, we must first find the intercepts and the traces. So, let's solve in. Now, function of x and y is equal to square root of 4 minus 4x squared minus y squared. Now, first, we're going to let this f of x and y be z. Now, z is equal to 4 minus 4x squared minus y squared. This is now our function. Now, first, find the intercepts. Now, we have three intercepts, the z, x, and y. So first, find the z-intercepts. In finding the z-intercepts, we must first x is equal to 0 and y is equal to 0. So let's copy this function. Z is equal to square root of 4 minus 4x squared minus y squared. Now substitute the value of x and y to our function. So z now is equal to 4 minus 4x squared. Since x ito, magiging 0 squared. Same with y squared, 0 squared. Now, z now is equal to square root of 4. Now, square root of 4 is 2, right? 2. So, z is equal to 2. So, we have 0, 0, 2. This is the x, this is the y, and this is z. Next, we're going to find x intercepts. Now, in finding the x-intercepts, first we let y is equal to 0 and z is equal to 0. Copy this function. Z is equal to square root of 4 minus 4x squared minus y squared. Now substitute the value of y and z to our function. We have magiging 0 is equal to square root of 4 minus 4x squared minus 0 squared. It becomes 0 is equal to 4 minus 4x squared. Now squared both sides. So ito magiging 0 squared is 0. Ito magiging 4 minus 4x squared. Now 4x squared is equal to 4. Divided by 4 both sides. become x squared is equal to 1, since 4 over 4 is equal to 1, right? Now square root, so x now is equal to square root of 1 is 1. So we have now x is equal to 1 and z is equal to 2. So since it is a square root of 2, this square root of 1 is ito magiging positive or negative 1. So we have negative 1, 0, 0, and 1, 0, 0. Since ito x, di ba? Now next, find the y-intercepts. Now in finding the y-intercepts, we have first, let z is equal to 0 and x is equal to 0. Let's copy again our function. So z is equal to square root of 4 minus 4x squared minus y squared. Now substitute. So z now is equal to 0. 4 minus 4, 0 squared minus y squared. So it will become 0 square root of 4 minus y squared. Again, square both sides. So 0, 4 minus y squared. Now y squared is equal to 4 square root of y squared and square root of 4. Square root of y squared is y, and square root of 4 is positive and negative 2. So we have 0, negative 2, 0, and 0, 2, 0. Now since we have already found the intercepts, next we will proceed in finding the traces. So on traces, we have also three traces. We have the x, y plane, the xz plane, and yz plane. Now first, let's proceed here in xy plane. Now in xy plane, we let z is equal to 0. Now again, our function is z is equal to 4 minus 4x squared minus y squared. Now the purpose of the traces is enable for us to figure out or to visualize what is the form of the graph. So in xy plane, we let z is equal to 0. So 0 is equal to 4 minus 4x squared minus y squared. Squared both sides. So 0 is equal to 4 minus 4x squared minus y squared. Ito magiging 4x squared plus y squared is equal to 4, right? So divide both sides by 4. This one will become x squared over 1 plus y squared over 4 is equal to 4 over 4 is 1. So as you can see, this is an ellipse, right? We have x squared over 1 squared plus y squared over 2 squared is equal to 1. So this is an ellipse. So xy plane is an ellipse. Now, how about in xz plane? So in xz plane, we will let y is equal to 0. Now, copy again our function. Z is equal to square root of 4 minus 4x squared minus y squared. So z is equal to square root of 4 minus 4x squared minus 0 squared. Now, z is equal to square root of 4 minus 4x squared. Next, as you can see inside the square root, we can factor out the 4, right? So 4, 1 minus x squared. So, now, z square root of 4 is 2, and square root of 1 minus x squared. As you notice, this one, the xz plane, is it look like a upper half of a circle with a radius of 1. So the xz plane look like a half of a circle. Again, in xy plane we have an ellipse, and the xz plane is upper half of a circle. Now how about the yz plane? So in yz plane, we will let x is equal to 0. Now copy again our function z is equal to 4 minus 4x squared minus y squared. So z is equal to 4 minus 4 squared minus y squared. Now z is equal to square root of 4 minus y squared. So z now is equals to, again, ito, 4 minus y squared. Now it also look like an upper half of a circle with a radius of, since 4 ito, so magiging radius of 2. Radius of 2. Now, we can now graph the function by those information, the intercepts, and these traces. We have an ellipse, half of a circle, and also half of a circle. So, let's graph the function. I already draw an x, y, z plane, or the Cartesian plane. So this is the z, and this is the z, this is the x, and this is the y. Now, again, our intercept kanina is z is equal to 2. I will use black ball pen. So z is equal to 2. We also have x is equal to positive and negative 1, and y is equal to positive, negative 2. And our traces is the xy plane is an ellipse, xz plane, circle, half of a circle with a radius of 1, or is equal to 1. And the yz plane is also half of a circle with a radius of 2. Now, let's put first the intercept. So z is equal to 2. So since this is our z, so 1 and 2. So z is equal to 2. Kita. Next, we have the x is equal to positive and negative 1. So this is the 1, and this is the negative 1. Next is the y. This is the y. We have positive and negative 2. So negative 2 and positive 2. Now, in xy plane, since our x, this is the x and this is the y. So x and y plane now is an ellipse. So this intercept will form an ellipse. So let's connect, drawing an ellipse. Yun. Now, next is the xz plane. So we have x and z plane. It is half of a circle with a radius of 1. Since this is the x and this is the z, so we can connect this point half of a circle. So from here to here, here to here. I'm not good at drawing. So it is half of a circle with a radius of 1. As you can see, this is the radius. We have 1 and goes on 1. So it looks like this, half a circle. Also, the YZ plane. In YZ plane, so we have radius of 2. So this is Y and it is Z. So let's connect these points. Hmm. So the graph looks like this. This one. So this is the graph of f of x and y is equal to square root of 4 minus 4x squared minus y squared. Now let's proceed on item number 2. Item number 2, we have f of x and y is equal to 10 over x squared plus y squared plus 1. We're going to graph this function with the same process from item number 1. So we start solving. Again, copy f of x and y is equal to 10 over x squared plus y squared plus 1. We will let this f of x and y be z is equal to 10 over x squared plus y squared plus 1. This is now our function. The first that we're going to do is to find the intercept, right? So find the intercepts. So we have the z intercepts, the x intercepts, and y intercepts. Now first, we will solve the z-intercept. Again, pag z-intercept, we will let x is equal to 0 and y is equal to 0. Now, copy this function. So z is equals to 10 over x squared plus y squared plus 1. Now substitute the value of x and y. So we have z is equal to 10 over 0 squared plus 0 squared plus 1. So z is equal to 10 over 1. And 10 over 1 is equal to z is equal to 10. So we have 0, 0, 10. That is our z. How about our x? Pag x-intercept, we let z is equal to 0 and y is equal to 0. So z is equal to, copy again the function, 10 over x squared plus y squared plus 1. Now substitute the value of z and y. So ito magiging z, ito magiging 0 is equal to 10 over x squared plus 0 squared plus 1. So 0 is equal to 10 over x squared plus 1. Now, this function has no intercept. As you observe, if we let x is equal to any number, there is still this expression is never be 0 for any real x. Kasi whatever the value of x, meron talagang value. So, kahit ilagay mo dyan 1, merong value. So, this expression is never be 0 for any real x. So, it has no x-intercept. Now, we have y-intercept. Now, let's, again, x is equal to 0 and z is equal to 0. Copy the function. Z is equal to 10 over x squared plus y squared plus 1. Now, substitute. 0 is equal to 10 over 0 squared plus y squared plus 1. 0, 10 y squared plus 1. It's the same with the x-intercept. So meaning it has no y-intercepts. No y-intercept because this expression is never 0 for any real y. Kahit 0 man lagay dyan, merong value. Kahit anong value ni y, meron talagang value. So, this expression is never 0. So, in z-intercept, we have 10. Say, in x-intercept, walang x-intercept and wala ding y-intercept. Now, let's proceed in finding the traces. Now, second is traces. Second is traces. So again, we have the function z is equal to 10 for x squared plus y squared plus 1. Now in traces, we have three traces. We have xy plane, xz plane, and yz plane. Now, let's first find the traces in xy plane. So we let z is equal to 0. So let's copy this function. Z is equals to 10 over x squared plus y squared plus 1. Now, substitute 0 to our z. So 0 is equals to 10 x squared plus y squared plus 1. Meaning, as you can observe, no traces in the xy plane because it never reaches z is equal to 0. Meaning, it has no traces in the xy plane because it never reaches z is equal to 0. Now, how about in xz plane? So in finding the traces in xz plane, we'll let y is equal to 0. Now let's substitute our function. Copy the function first. Z is equal to 10 over x squared plus y squared plus 1. So we have z is equals to 10 over x squared plus 0 squared plus 1. Z is equal to 10 over x squared plus 1. So as you can observe, this is a curve, a curve that decreases as x increases. It look like a it look like a vertical cross section of a plane of a dome, sorry. Cross section of a dome. Meaning, look like this one, ganito. Ganito siya, something. Oo. Diba dome, parang ganito yung dome. Diba ganito yung dome. So, meaning, vertical man. So, next, we have the YZ plane. So, in YZ plane, we let x is equal to 0. So, z is equal to 10 over x squared plus y squared plus 1. Z is equal to 10 over x squared, 0 squared plus y squared plus 1. Z is equal to 10 over y squared plus 1. It also curve. Curve. But this time, it is symmetrical around, same with xz plane, but in yz plane, it is symmetrical. It is symmetric around y is equal to 0. Since it is um, the figure of in yz plane, it look like this one, but it is symmetric around the y is equal to 0. Since we have those information, we have the intercepts and the traces, we can now graph this function. So I already draw a Cartesian plane. Where is my Cartesian plane? I already draw a Cartesian plane here. Now I will going to write again the intercept. Intercept, we have z is equal to 10 in x, no intercept, and y, it also have no intercepts. Now in traces, we have in xy plane, we have no traces. In xz plane, we have a curve. Same with yz plane, but this time a curve that is symmetric around y is equal to 0. Since we have these informations, we can now graph the function. So again, let's put the intercept. Z is equal to 10. So this is our z, this is our x, and this is our y. So we have z is equal to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. Since it has no x-intercept and y-intercept, so we don't have points in this axis. But it doesn't mean na wala tayong figure. So let's proceed to our traces. So in xy plane, ito at xy plane, it has no traces. Ito, x and y. So since walang intercept, wala ding traces. Now how about in xz plane? Since ito ang x, ito ang z. So it has daw a curve. So since ito yung z, we have 10, and ito yung x, so it is a curve. So meaning, a curve, diba? Matawagin na. A vertical cross-section of a dome. It look like a cross-section of a dome. So meaning, look like, ano bang ganito? Ganito. Ito dyan yung x, diba? Here, since ito yung x, ganyan. So hindi siya didikit sa axis, sa x-axis kasi walang intercept dyan eh. So next, we have YZ plane. Ito yung y, ito yung z. Same, it is a curve, but this time it is symmetric around y is equal to 0. So ito yung y is equal, ito yung 0. So again, and this is the y, so it look like this. Lang ba? Paano ba to? Oops. Ano to? Hold on. Ganun. Ganun. Tapos dito din sa kabila. Ganun. Ayun. Parang ganito. So, this is the graph. So, kahit dyan. Saan yan pupunta? Ayun. So, this is the graph of f of x, y is equal to tan over x squared plus y squared plus 1. So, that is the problems involving the function of more than one variable. Now, let's proceed to our topic 2, which is the limits and continuity of functions of more than one variable. So, I have here a problem. First, we have find the limit if it exists or show the limit does not exist. We have item number 1, limit of x and y approaches to 1 and 1, e to the power of x minus y plus cosine xy. And our item number 2 is limit of x and y approaches to 0 and 0, x squared minus y over x squared plus y. So let's proceed with item number 1. So in item number 1, we have limit of x and y approaches to 1 and 1, e to the power of x minus y plus cosine xy. Now, our goal here is to find the limit if it exists, and if it does not, then we will show that this limit, let's show that the limit does not exist. So in solving this problem, we will use the first technique in limits, which is the substitution. That is the first thing that we need to do. Now let's try solve in. We have uh, direct first, direct substitution. This is, but if you are evaluating a limit, this is the first thing that you need do first, which is the direct substitution, which is we have limit x of y approaches to 1 and 1, e the power of x minus y plus cosine xy is equal to, now the value of x here is 1 and the value of y here is 1. So let's substitute 1 to the x and y. So e 1 minus 1 plus cosine 1 times 1. Now e 1 minus 1, which is e 0 plus cosine 1. Now e to the 0 is equal to 1. That's correct. Plus cosine 1. Cosine 1 is approximately 1.5, basta ganyan. So meaning the limit exists. Therefore, limit x, y approaches to 1 and 1, e to the power of x minus y plus cosine xy is equal to 1 plus cosine 1. Therefore, the limit exists. This is our conclusion. Now let's proceed to item number 2. So in item number 2, we have item number 2 is limit of x and y approaches to 0, 0, 0 and 0, x squared minus y over x squared plus y. Again, in solving the limit, let's try first the direct substitution. So solve in. We have direct substitution. Let's copy the limit x, y approaches to 0, 0, x squared minus y, x squared plus y is equal to, now, again, x is equal to 0, right? And y is approaches to 0. So let's substitute 0 to this function, expression. So we have 0 squared minus 0 over 0 squared plus 0. It is 0 over 0. It is indeterminate since the limit is 0 over 0. Therefore, it does not exist. Since the limit is 0 over 0, it means that the domain of the function f(x) and y is equal to x squared minus y over x squared plus y consists of all points in the xy plane except for the point 0 and 0. To show that the limit as x and y approaches 0 and 0 does not exist, let's consider approaching 0 and 0 along two different paths. So, let's try to approach two different paths. First is along with x-axis. Every point is of the form. Every point, is of the form x0, and the limit along this approach is limit. Let's copy this. X, y approaches to, since along with x-axis and x and 0, so ito magiging x 0, x squared minus y over x squared plus y. So the value of x now is x, so let's substitute. So it will be still x squared minus the value of y is 0, 0 over x squared plus 0, magiging x squared over x squared, or equal to 1. So along with x-axis, it has limit of 1. Now let's proceed with along with y-axis. Along with y-axis, every point is of the form 0, y. And the limit along this approach is limit x, y approaches to, ito, 0, y, x squared minus y minus x over x squared plus y is equal to, since our x now is 0, so 0 squared minus still y, 0 squared plus y, it is negative y over y, meaning negative y over y is negative 1. So as you can observe, we have, along with x-axis, we have positive 1, and along with y-axis, we have negative 1. Since it has two different limits along two different lines, so again now we have 1 and negative 1. It has two different limits along different lines, the x-axis and y-axis. Therefore, the given limit does not exist, meaning we already show that this limit does not exist. So the conclusion is, since function has two different ala, different limits along two different paths or lines, the given does not exist. That is the problem of limits and continuity of function of more than one variable. Now, let's proceed to our last topic, which is the partial derivative. Now, I have here two problems. We have find the first and higher order partial derivative of x and y is equal to x squared y plus 3xy squared. And item number 2 is f of x and y is equal to tan 3x cos xy. Now, let's start with item number 1. We have f of x and y is equal to x squared y plus 3y squared. First, find the first partial derivative, right? We will find first the first order partial derivative. Next is the higher order partial derivative. Now, to solve the first order partial derivative, we will let f of x and y be z is equal to bz is equal to 2x squared y plus 3xy squared. This function ating gagamitin. So, let's find first the first order partial derivative. Now, the first order partial derivative, we have partial of z with respect to x. And yung a natin, yung b natin. Partial of z with respect to y. Now, we will derive this with respect to x and with respect to y. Partial derivative. So, let's start with a. Partial z with respect to x. Copy our equation, x squared y plus 3xy squared. Now, how to derive this with respect to x? Remember, since we are deriving this equation with respect to x, we will let y as constant. So, x squared derivative of x squared y with respect to x is 2x and y, since y is a constant, plus ito 3xy squared, derivative ng 3xy squared with respect to x, so ito magiging 3, copy the constant y squared. So this one, our partial derivative of z with respect to x. Now how about our b? Partial derivative of z with respect to y. Let's copy our function, x squared y plus 3xy squared. Now since we were deriving this equation with respect to y, so we will let x as constant. So derivative ng x squared y with respect to y, it is x squared plus ang derivative ng 3xy squared, since we will let x as constant, so ito copy the 3x. Derivative ng y squared is 2y. So multiply x squared plus 3x times 2y is 6xy. This is now our partial derivative with respect to y. Now, how about the higher order partial derivative? Now, let's copy first this 2. So we have partial z partial x is equal to 2xy plus 3y squared, and partial z with respect to y is equal to x squared plus 6xy. Now next is finding the higher order partial derivative. In finding the higher order derivative, we have 4. Higher order. So we have 4. We have first the a is partial squared z over partial x squared. B, the second is partial squared z partial y squared. C is partial squared z partial xy. And D is partial squared z over partial yx. As you can notice, we have partial squared z, right? Meaning, we will derive the function kaduha, since it is higher order. So let's start with A. we have partial squared z with respect to x squared, meaning partial of with respect to x, and again we will derive kadwa, so may partial of z with partial of x. Ito yon. Since we already have partial z over partial x, ito yon. So let's copy that one. So 2xy plus 3y squared. Now we will derive this again with respect to x na naman kasi x squared, di ba? So ito 2xy plus 3y squared. So derivative ng 2xy with respect to x is 2 2, and y is a constant, right? So 2y plus 3y squared, since y is constant, and since 3y squared is constant, so derivative ng constant is 0. So meaning our partial squared z over partial x squared is 2y. Now let's proceed to b. We have partial squared z partial y squared. Partial of y, partial over partial y, partial z with respect to y. Now, since we already have this one, si partial z over partial y, ito yun, di ba? So, partial y, x squared plus 6xy. So, derive natin ito ulit with respect to y. So, x squared, since x squared is a constant, meaning derivative ng constant is 0, plus 6xy. Derivative ng 6xy with respect to y, we have 6x. This is now our partial squared z over y, partial y squared. Now let's proceed to c. We have partial squared z over partial xy. As you can observe, we have xy, right? So we will derive from right to left. So meaning from y to x. So we will derive the function first by y and again by x. So ito magiging partial x and partial z, partial y. Boom. So again, we have partial z over partial y. Ito, di ba yun? So we can now easily copy that one. Mag x squared plus 6xy. We will derive it again with respect to x. So x squared, derivative ng x squared with respect to x is 2x plus 6xy with derivative ng 6xy with respect to x. So we have 6y. This is now a partial squared z over partial xy. How about d, the last one? We have partial squared z over partial yx. Now, we will derive the function first by x and second by y. So meaning, partial of y times partial z partial x. So, partial of y. Ito diba, partial z partial x. Ito yan, 2xy plus 3y squared. So, 2xy plus 3y squared. So, let's derive this with respect to y. So, x will be constant. So, 2xy, derivative ng 2xy with respect to y. So, ito magiging 2x plus derivative ng 3y squared with respect to y. Ito magiging 2 times 3, 6y. So, ito yung partial squared z over partial yx. So, we already found the first order partial derivative. Ito yung first order. And the higher order partial derivative. Now, let us proceed to item number 2. We have f of x and y is equal to tan 3x cos xy, cosine xy. It is a little bit complicated because we will use chain rule and product rule of derivative. Now, let's find first the first order partial derivative. But before that, we will let f of x and y be z. So, z is equal to tan 3x cosine xy. Let's proceed to first order partial derivative. First order, again, we have a partial z with respect to x, and b we have partial z with respect to y. So let's start with a, partial z with respect to x. Let's copy first this one. So tan 3x cosine xy. Now let's derive this function with respect to x. Now we have tan 3x. First, what is the derivative of tangent, which is secant squared. Copy the 3x. Next, what is the derivative of 3x, which is with respect to x, which is 3 times 3. Next, copy the cosine xy plus, ito naman, cosine xy. So copy the tangent 3x. Diba? We'll use the chain rule and also the product rule. So copy the tangent 3x. Next is, what is the derivative of cosine xy with respect to x? Derivative ng cosine is negative sine. Copy the xy. Now derivative ng xy is with respect to x is y. Meaning partial z respect to x is secant squared 3x times 3 cos xy. We have 3 secant squared 3x cosine xy. Ito, since we have negative sign here, positive times negative, which is negative. So we have y tangent 3x times sine xy. We have tangent 3x sine xy. This is now the partial derivative of z with respect to x. Now how about our letter B, partial derivative of z with respect to y? Let's proceed. Partial z with respect to y. Let's copy again. We have tan 3x cosine xy. Now, since as you can observe, cosine xy has the only na ay y, diba? So meaning, tan 3x is a constant. So let's copy tan 3x. Now, derivative ng cosine xy, derivative ng cosine is negative sine. Oops, negative sine xy. Now, derivative ng xy is x times x na magiging tan 3x times negative x sine xy. So simplify partial z with respect to y. Tan 3x times negative x sine xy, we have negative x tan 3x sine xy. This is now the partial z with respect to y. We already found the first order derivative of this function. Now let's proceed to higher order partial derivative. So let's copy first the dz. Ito, partial z partial x is equal to 3 secant squared 3x cosine xy minus y tan 3x sine xy. And partial z with respect to y is negative x tan 3x sine xy. Now again, the high order partial derivative consists of 4. We have a, the partial squared z over partial x squared. We have b, we have partial squared z with respect to partial y squared. And c, we have partial squared z respect to partial xy. Lastly is d, partial squared z respect to yx. Now, let's start with letter A. We have partial squared z over partial x squared. Now, with this partial squared z over partial x squared can be written as partial x partial z over partial x. As you notice, this one, partial z with respect to x, this is, diba ito yun? So, partial x, let's copy that one. 3 second squared 3x cosine xy minus y tan 3x sine xy. Now let's derive this one with respect to x. Medyo mataas-taas to isa. So, the 3 second squared 3x cos xy. So you can observe we can use power rule, product rule, and also chain rule, syempre. So let's start. We have derivative ng 3 second squared 3x. Ito muna. Copy the 3. We have second squared, diba? So making 2 second 3x na. Next, ang derivative ng second, which is second 3x tan 3x. Am I right? Next, ang derivative ng 3x with respect to x, which is 3. Copy cosine xy. Now, apply product rule. Since we already done deriving this, let's proceed to this. Malagay mo plus. Copy natin ito. So, 3 second squared 3x derivative ng cosine xy is negative sine xy. Derivative ng xy with respect to x, which is y. Now, let's proceed naman dito. So, minus y tan 3x, copy y because it is constant. Derivative ng tangent. Derivative ng tangent 3x is secant squared 3x. Copy the, derivative ng 3x with respect to x is 3. Now, copy sine xy. Sine xy. Plus, ito naman yung derivative natin. So, copy y tan 3x. Y tan 3x. Ang derivative ng sine y, we have negative cosine y. Cosine xy natin. Cosine xy. Derivative ng sine xy, we have negative cosine xy. And derivative ng xy with respect to x, we have y. So, simplify natin guys. Ang haba nito guys. Ang haba. Dito muna natin. Simplify natin. Kita ba sa camera? As you can observe, merong 3, tsaka merong 3 din dito. Okay, factor out natin. Labas natin. So, ito magiging 3, ito, 2 second 3x times second 3x tan 3x times 3 cosine xy. Ito muna. Ito may 3 times 2, we have 6. Second 3x times second 3x tan 3x, we have second squared 3x tan 3x. Now we have cosine xy. Cosine xy plus, plus, ito muna, Nilabas natin yung 3. So, second squared 3x times negative sine xy, y times y. Ito magiging negative y sine, y sine xy, tsaka second squared 3x. Yun. 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 We're done with this. Now, let's proceed to this. Simplify natin yan. So, you can observe, merong y, tsaka merong y divided dito. So, labas natin yung y, gaya ng 3. Now, second squared 3x times 3 sine xy, we have 3 second squared 3x sine xy plus we have y tan 3x. Wait, not negative cosine xy. Derivative ng sine xy is sine. Derivative ng sine is cosine. So, dapat hindi ito negative. Cosine xy yan. Meaning, plus, ilabas natin itong y. Ito lang, tan 3x times cosine xy times y. So, may itong y tan 3x times cosine xy. Am I right? Ayun. Tapos guys, remove natin muna ito. Next, ito muna natin. Is equal to, ito muna. So, 3, 6 second squared 3x tan 3x cosine xy. Positive times negative, we have negative y second squared 3x sine xy. Tapos, meron tayong negative y 3 second squared 3x sine xy plus y tan 3x cosine xy. Ayun, mas klaro. Next, distribute na natin si 3 at saka si y. So, 3 times 6, we have 18. 18 second squared 3x tan 3x cosine xy minus 3 times y, we have 3y. 3y second squared 3x sine xy. Yun. Una. Minus. We have distribute natin si y. So, y times 3 is 3y. Second squared 3x sine xy plus y times y, we have y squared tan 3x cosine xy. Then, hindi pa yan naka-distribute. Kasi plus pa yung ginamit natin, so hindi pa ito naka-distribute. So, simplify naman ulit. Distribute na natin yung negative sign. So, ito magiging 18 second squared 3x tan 3x cosine xy minus 3y second squared 3x sine xy. Ito magiging minus 3y second squared 3x sine xy minus y squared tan 3x cosine xy. Yun. Next. Wait, ano pa bang mas simplify? Ayun, ito. Ito at saka ito. We can add this 2, right? Kasi parehas. Same sila. Second squared 3x. We can simplify that one. So 18 second squared 3x tan 3x cosine xy negative 3 plus negative 3. So we have negative 6 y second squared 3x sine xy minus ito minus y squared tan 3x cosine xy. Ayun! I think ito na yun. So this is the partial squared z with respect to partial x squared. Haba. Ano guys? Ngayon, higher order derivative with partial squared z over partial x squared. Now let's proceed to letter b. Ang b natin is ayan. Letter b, we have partial squared z over partial y squared. It can be written as partial y, partial z over partial y. Now, partial z over partial y, ito yun, di ba? So, let's copy that one. Partial y. Negative x tangent 3x sine xy. Now, let's derive it again with respect to y. As you can observe, tan 3x unang y. Dito lang sa sine xy. So, let's make this as constant. So, copy that one. So, ito magiging negative x tan 3x. Derivative ng sine xy. Derivative ng sine is cosine xy. Derivative ng xy with respect to y, we have times x. So, ito magiging negative x times x, which is negative x squared tan 3x cosine xy. This is the partial squared z over partial y squared. Yung now let's proceed to other one. The partial wait, magkasya ba? Partial squared z over partial xy. Can be lang. Remove natin ito guys para magkasya. Ayun. Tapos C natin ito ha. C na lang. Haba na ito guys. So, partial x, partial z, partial y. Yung partial y natin, ito ulit. Tama? So, let's copy that one. So, we have negative x tan 3x sine xy. Ayun. Now, let's derive this with respect to x. Now, negative x, derivative ng negative x is negative 1. So, remove natin ito. Natin sa negative dito muna. So, copy si tan 3x. Plus, copy na naman natin yung si x. Derivative ng tan 3x is wait. Para di tayo malito guys. Yung negative, ilabas natin muna. So, derivative ng negative x tan 3x with respect to x. Diba? Derivative ng x is 1. So, tan 3x plus copy the x. Ito yun. Tapos derivative ng tan 3x is derivative ng tan is secant squared 3x. Tapos derivative ng 3x with respect to x is 3. Yun. Copy the sine xy. So, multiply pala. Yun. Next. Plus. Ito naman yung i-derive natin. So, copy natin ito. So, negative x tan 3x. Derivative ng sine xy is cosine xy. Derivative ng xy with respect to x is y. Yun. Simplify na natin guys. After natin ma-derive lahat. Simplify na natin. Ito, distribute na natin guys. I know. Let's multiply this muna. So, ito magiging 3 x. Tapos yun, tan 3x secant plus secant squared 3x sine xy. Yung plus ito, multiply natin pang y pang x. Magiging negative xy tan 3x cosine xy. Simplify natin ulit. Distribute natin si negative sign dito. So, ito magiging negative 3x tan 3x. Negative times positive, negative. Secant squared 3x sine xy. Yun, ito. Positive times negative. Negative xy tan 3x cosine xy. Ayun. Tama ba ako guys? Negative 3x tan 3x minus yes, I think that is correct. Tama naman. This is now the partial squared z partial xy. Sorry. Ito yung sagot. O, isa na lang. Let's proceed to letter D. D. At D we have partial squared z over partial yx. So it can be written as partial y, partial z with respect to x. Since x, we will derive first with respect to x, next is with respect to y, diba? So partial z with respect to x, ito yun. Diba? Ayan. So let's copy that one. 3 secant squared 3x cosine xy minus y tan 3x sine xy. Now, let's derive this with respect na naman kang y. So, let's start. So, ito, 3 secant squared 3x cos xy. As you can observe, cosine xy has the only one na ay y. So, meaning, this one will be constant. So, ito magiging 3 secant squared 3x. Derivative ng cosine xy is negative sine xy. Ang derivative ng xy with respect to y is x. This. Now, let's proceed to this one. To the side. So, derivative ng y with respect to y is 1, right? Now tan 3x, this is a constant, so let's just copy this one. Tan 3x sine xy. Now let's derive. Hindi natin ito i-derive yung tan 3x kasi constant yan. So now let's derive sine xy. Ang derivative ng plus tayo dito guys, plus tan 3x and y tan 3x itong sine xy. Ang derivative ng sine is cosine xy. Next is ang derivative ng xy with respect to y. So x. Now let's simplify everything. So we have ito magiging negative 3x yan, second squared 3x sine xy. Next, let's simplify first this muna bago tayo distribute itong negative. So ito magiging tan 3x sine xy. Sine xy. X times y plus xy tan 3x cosine xy. Now, let's distribute the negative sign. So ito magiging negative 3x second squared 3x sine xy. Negative times tan 3x, ito magiging negative tan 3x sine xy. Ito magiging negative xy tan 3x cosine xy. Yun. So this is now our higher order partial derivative of partial squared z over partial yx. This is now our answer.